Yeah.
Is our 360 vibe. All right.
All right, so settling in here. I don't know too much about this campus, but, well, Alex does. What I can tell you is this is a gay classroom, I guess, in building E38.
This is, I think, the Welcome Center, where now in front of us here, they bring in, they have like one of the really chipper MIT undergrads come in and pronunciate and enunciate to a whole stadium full of people to get them oriented for their experience walking around. So it's only fitting that we talk about an AI system in this room, of course.
Yeah, welcome to your Shirley orientation. More seriously, though, we wanted to take an opportunity to kind of post-mortem the air tour that we just did. So we spent about 9 days flying around various cities in the Midwest, like Louisville, Oshkosh, Gary,
Chicago,
yeah, a couple other places we landed, and we met a bunch of people who are in this aviation world, and I think we really validated the product that we've built thus far, and demonstrated how we can take this product that we built kind of with simming in mind and actually bring it from sim to sky, which was kind of one of the major goals of Fly Shirley and airplane team broadly. But yeah, we just wanted to take an opportunity to talk about things that went right, and eat just as interestingly the things that went wrong.
That could be done better.
Yeah.
Could be better. Yeah, exactly. Yeah.
So yeah, we have a little spot the difference right here. We'll edit this in, but the gist of it is, so as we were taking off from I-69 Airport in Batavia, we noticed on run-up that our Starlink was looking a little bit loose, and we took off.
There's one suction cup down.
Yeah, we started to notice that performance was not super good on the whole internet thing, and I turned around and the antenna's gone. And I don't mean gone like that. I just mean like into the bottom of the trunk. But it needs to be able to see satellites, and that proved to be a major issue with connectivity.
What was really interesting was that it was still pointing through the tail cone of the aircraft, but while it was pointing through the tail cone of the aircraft, it still had internet connectivity.
Yeah, a little spotty, a little unpredictable.
Download was still very good.
yeah. But one
Upload
of our
was bad.
Right, and it turns out we need that. We have an offline speech to text model, and we need to be able to ferry speech to that model.
We have an offline one now.
Yeah.
But we were using that one on the ground, right? We weren't using the one on the laptop during that flight.
Right. We were just kind of like getting our bearings with the whole system, and we also expected to have pretty good connectivity.
We got the satellite dish, therefore it's going to be great.
Yeah. High-speed broadband in the sky, which is true on the download front, honestly, even at worst, which was interesting. But yeah, we were able to get some useful data out of that flight. We were able to have like some level of conversation with Shirley.
Mostly because we were connected through the iPad on cellular 3G onto the ground.
True. Yeah. So we did have also Apache 3G connection to lean on as well. But yeah, the upshot was we noticed one problem that would kind of come up in various contexts throughout, which was that you can't always super easily tell if Shirley's there. And so Shirley can emit some sort of reassuring pops and sort of noises to indicate that a search is happening and so on. And we
reassuring hisses and clicks. No, something a little better than that.
Yeah, but we need to be doing more. We need to more kind of
oral
just
tones.
sort of light oral audio feedback. To help the user understand that okay, the assistant's still there and you don't need to do what we do, which is start being okay, Shirley, are you there? Let's do a debug query. How about a research query? We end up putting together a big long backlog of additional query input, which makes it take even longer for us to start getting useful stuff back.
I will also say that it's hard to replicate those conditions on the ground because the way that it was dropped was really weird. I mean, it would just be it would just not be connected on satellite for a long time, and then you'd start getting connection again. Luckily, on our last flight, we were having intermittent connectivity challenges there. Mostly, it was really good. But, I was able to capture 3 hours of pings. because ever since I started having issues with internet, I've just been pinging constantly. My laptop just always pings. Thank you, Google, for responding to my pings every day, all day, every second. Yeah. But now we have the ping record, so I think we have some more of the ability to replicate that. Although the nature of the dropped packets is very it's strange.
And this really was one of our takeaways from the tour as well, that network connectivity is an important thing for us to understand in a pretty high resolution way. It occurred to us at some point that we could have been looking at the app that Starlink provides to understand the connectivity state between Starlink and the antenna versus our own networking on the plane. Currently, we just don't really know where the issues that we were having really reside. Is it between us and the router, or is it between Starlink and the internet? And what does that issue look like? We have some intuitions and some ideas, but we could definitely get more specific on that.
And we still don't have a way of replicating the exact conditions, which I think would be a goal of our next flight too.
Right. If we knew exactly how the network was failing, we could simulate it, and that would be really useful.
Or detect when that happens so we can degrade. Yeah. But I know that's another thing you wanted to talk about. Yeah.
But there's plenty. We'll be talking plenty about the degraded mode and our learnings about that. But kind of on a related note, here's a big one. Bad automated speech recognition is a showstopper. It actually makes it impossible to get the information you want, even if the LLM knows it all.
Even if it's a crazy smart LLM.
Right.
It helps to have a crazy smart LLM.
Useful for sure. But for example, our system has a wake word. That wake word is Shirley. It turns out that the NATO phonetic alphabet, which I don't know all of, begins Alpha, Bravo, Charlie. And so Shirley and Charlie actually sound quite similar.
When you go through an intercom, it sounds very similar.
Looking back through our logs of the actual responses that we were getting back from the model, the word Charlie appears in them many times, indicating that it's a common transcription failure, particularly in a high noise environment like a cockpit.
Yeah.
And so, one thing you might want to do is deboost Charlie so that maybe the model would be more likely to think that the word is Shirley. But then, of course, there's that other problem that we really need that phonetic alphabet because people use Charlie when they're reading an acronym.
And the separation is just really narrow.
Right.
But when the issue is you want to be waking up the model, proactively, but you also don't want it to be stepping on people and then speaking at times where it shouldn't. And so maybe part of it is that Shirley is just a really bad name to give in general, in part because it's hard to pronounce for the majority of the human beings on the planet. That's already true.
Yeah,
but it's a great name.
It's great. I mean, and I guess one thing we had discussed is providing an alternative wake word.
Right. Like airplane, for instance, which recognizes a bit better.
And it's way less common than you'd think inside the cockpit
when you're
of
actually
an actual
flying.
Airplane.
But then there's questions about the human factors of are you talking to the plane, are you talking to the person? These are really interesting questions. But
Right. I think it's a sad hit to branding to have to change that. So I don't know. Maybe we can get creative with it. I'm not sure.
If you boost, on the other hand, sometimes if you boost a word, then it doesn't have the downsides of deboosting words. But then you get it. It's not great.
There's also a great moment looking back to the transcripts where Alex asked the assistant to turn off assistant mode, and that's kind of get into its more conversational mode where it's not listening for the wake word. And so Alex checked the ASR results in flight and saw that what was being transcribed for some reason was the F-bomb, which I guess it's not so surprising that the LLM's getting F-bombs. And it's of course I'm supposed to turn off assistant mode. That's what the pilot is requesting with these F-bombs.
He totally implied it for some reason.
Yeah, and
it
didn't even have assistant mode in that chat line. And so basically, if ASR is not working, the information that is necessary doesn't reach the model, and the upshot is that the assistant becomes kind of useless.
I just think, yes. And I think we just need time to work with a particular ASR model to understand its quirks, because they all have quirks.
Yeah.
Even big ones, off-the-shelf ones like Deep Grammar or Google, they all have quirks too.
Right. And simulating those cockpit conditions as closely as possible. It occurred to me that the more we can kind of use the audio that was picked up by the 360 over the DJI microphone, Yeah, that'll really help us to like accurately simulate the compression of our voices that does occur when speaking through aviation headsets.
After the air tour, we have 13 hours or so of training data on that stuff, so that's pretty good.
Yeah, what I did hear from Roxy, who we also work with, is that the Shirley Charlie issue is actually very rare when using microphones normally.
And it's also challenging if you use like a headset, an aviation headset, and plug it into an intercom box on the computer. Well, it's not using the headphone in the same way as the intercom is. Basically, it's putting a voltage over it, but you get a really clean signal, and it's not broken by the intercom system.
Right.
It doesn't have all the noise of that environment. It doesn't have the engine noise. And you can't just overlay that noise because it's different than the actual nature of the noise in flight.
Yeah, I almost wonder if we might be able to use like an audio to audio model to like apply similar compression to our voices.
That's true. It's like have us say the words
right
that existed. Maybe that could be a thing.
Build a quick tool to kind of like simulate our voice, but in a cockpit.
Now we do have Austin Meyer's voice, and it was recorded through an intercom. That's a really interesting question. It's like, can we use that? Austin Meyer's the owner of X-Plane.
Yeah, it's really cool because it that one sounds really great for in-cabin usage, and I think it's largely because it came through an intercom.
It came through an intercom. It sounds like he's in a flight environment. So we should try that also. Sending it through a model, see if it's representative, see if when he says Charlie or Shirley.
yeah, it sounds like natural and real, like when you're flying with it, and that's great for an assistant.
But also for testing purposes, right?
Yeah. All right. So I guess moving on to our next topic, about Shirley's presence. I guess we touched on this already, but when the internet gets bad and Shirley's not there, it just takes a long time for a response to come back from the LLM. And
right.
In that circumstance, we don't offer any like helpful audio feedback or anything.
No, because we have retries. The backend logic is retrying multiple times after it times out.
Right.
And when you have high packet loss, TCP tries to recover, and long round trip times to space and back, then TCP tries to recover, and it just takes a very long time.
Right. The key there, I think, is really reassuring the user, which is just it's interesting because it's really far in some ways from like a deep technical solution. It's just more of a human problem. But it's something that we have the tools to figure out, and now that we know that, I'm certainly excited to start making those improvements.
Yeah, and it's like how far behind the covers do we want to go? You know, if there's 3 retries, do you want to hear like for 3 and then for 2 and then it's done, or the other way? I don't know.
Yeah,
but
I felt like some kind of like status awareness.
Yeah. But then there's like this thing of you only have your users being the most expert users.
Right.
And like nobody else can understand how the system works.
Right. Yeah. We should definitely try to make it as intuitive as we can, to where you don't have to like really understand, but it just kind of feels right. Like I think a product that really gets this very well is Google Maps. How like it plays certain different sounds when things happen, like the speed limit changing, and even if you don't necessarily recognize exactly which sound it is when that happens, it still kind of gives you an intuition that like you need to pay attention to something.
Yeah, exactly. Yeah, that's great.
But another thing to move on to is like ambient noise itself distracting Shirley. And we kind of ran into this problem fairly early on with like our current setup has Shirley receiving all the cabin audio. So that's me talking, that's Alex talking, that's the radio talking. And can Shirley hear Shirley?
Shirley can hear Shirley, but then I think there's built-in cancellation.
Okay. But yeah, basically Shirley is just sort of like, there in the fishbowl with all of us. And there were definitely times when Alex wanted to ask Shirley a question, and some stuff came over the radio at more or less the same time. And so there's no obvious like speech boundary between where Alex stops talking and where the radio is talking. And so as a result, we started leveraging the microphone mute feature in the application to like kind of end the utterance. But it turns out that button is sort of like, kind of a little opening menu, and it's like right next to the end flight button. And on a number of occasions, we inadvertently ended the flight while trying to mute the microphone.
Which is fine because we have a resume flight button, but just having to do that handshake again like adds a few seconds, and you lose a bunch of context, and you get pretty distracted.
Right.
You're like, are you actually flying the plane, or are you in the
So yeah, I guess two things came out of that. One is like, we need to be mindful of like how big our buttons are and how destructive the actions they can do in one click are. And then the other is we started talking about push to talk.
And we implemented some things.
Yeah.
To the rudimentary level, right?
Right. In particular, we now have this priority wake up feature, which basically tells Shirley you can wake up and start talking after you hear your name.
So there's two things, right? There's one of them is we have this back off system, and so the back off system will go, and if you keep on stepping on Shirley as Shirley speaks, Shirley progressively starts to respond slower, because most of the time what you want is the fastest possible response. But it turns out sometimes, hey, you actually got too fast, and now you're stepping on certain people in certain circumstances, and it's just like, that's also not fun for those people. Yeah. And so the opposite problem also came up. And so we had to build this back-off system. And then so we had the system when you say Shirley, if that's like one of the last sentences in the last sentence you said, then it'll get rid of all the back off. The priority wake up thing was specifically with push to talk in order to make Shirley speak over us, even if we continue to speak or if somebody on the radio did. And that, in some ways that helped.
Yeah, it's definitely like a kind of orchestration problem that we need to continue to refine.
Yeah. But you have, some of the experiments that you've done with the audio to audio models, like that's, I think, going to be the next genesis of all this. Maybe we should be talking about that at the end of this video, but.
Yeah, certainly the audio to audio models latency, when they have a really good connection at least, and there's ways that we can bring that about in the cabin in particular. The idea that we have is running it on an iPad. Yep. Would give the ability to have like kind of millisecond level resolution as to sort of like who is speaking and when they stopped and yep. So on. And I think having that in the loop will enable us to get a much kind of tighter and more realistic conversation going with the assistant. Okay, so moving on to another one, we noticed, and we kind of knew this beforehand, but LLMs and spatial reasoning. There were a number of things going on here. One thing that I repeatedly did on flights was just asking about local landmarks. I find it interesting to sort of learn about our sort of spatial position relative to the other things that are around. And so I was asking about features like rivers and lakes. So there was this the Little Miami River we asked about, and I was like, "What's that river coming up?" And Shirley says, "Oh, it's the Little Miami River." And
4 out of 5 times we asked what river something was, we got something Miami River.
Yeah. So we were kind of unsure first off if the other Miami River was real, but no, Shirley was right about that. But the big problem was that we were at what's that river coming up? It's the Little Miami River. So we fly over it, keep flying for 10 minutes, and we're like, Shirley, what was that river that we flew over? And Shirley's like, oh, the river that's coming right up is the Little Miami River.
I thought Shirley said in that case this is the Big Miami River.
Well, there was one where it's just kind of like the Little Miami River was like, is it behind us or is it in front of us? Shirley was really confused on that point.
You're right.
And
or what's off our right wingtip.
Right. A similar case with there was a refinery off our right wingtip, and there was a way bigger and more interesting refinery in front of the plane. And I kind of suspect that model probabilities, since there's probably just more discussion about the refinery in front of us,
directly next to Chicago.
Yeah, the BP Lansing complex
versus the
90 acres of refinery, I guess.
Yeah, versus the one that's in Lafayette near Purdue.
Yeah. The other one was cool too, but yeah, it's certainly no BP Lansing. Anyway, yeah, Shirley was just all about talking about BP Lansing.
And you think part of that is probably due to, if we had Shirley be able to do reasoning, because it's this trade-off, right? Because you want to be able to have reasoning go into making a response so that it's truthful and that it actually knows, it can think through the sines and cosines in order to figure out what's off your right wing, what's not. But by the time you do that, you've got 4 seconds of latency for this model.
Yeah.
And sure, we've tried out the OSS 120 billion parameter model, but it is also not that smart even when it does that thinking, even if it can do 2 paragraphs of thinking and be able to respond within a second.
Yeah, that's actually a great segue into our next topic, which is that as of right now, that model is just a little too dumb.
It's just a little too dumb. It still runs on the MacBook Pro.
Yeah,
which is cool,
and it kind of it speaks semi-intelligibly. But it's
sort of smart.
It doesn't say welcome to Middletown. it says "Welcome Middletown," and there's just lots of interactions with it where
Did it really say that?
I was like reviewing the footage and I'm like, oh my god, it's just like, it's like whatever. Who needs prepositions? They are kind of superfluous.
So sometimes that can be the text to speech also. But some of those, but it is basically at that level.
Yeah. We need to check the logs on that point. But the OSS model was really not answering even kind of moderate complexity questions, and it kind of like felt clearly below a level where it's just sort of like intellectually useful as a pilot.
It's not intellectually useful as a pilot, not even as a backup. I think I would prefer to scroll and find the thing myself.
Yeah.
Which is unfortunate because the only version that would run on the iPad is the 12 billion parameter one, which would be nowhere near as smart as the one that's still not smart enough even remotely.
Yeah. Luckily, for reasons we'll get into later, we don't necessarily think this is such a big problem.
Yeah.
That's pretty much an exhaustive list of the things that were really kind of challenging, like with regard to interacting with Shirley on the trip. And now we get to talk about the things that went well. One that I'll just say out of the gate is flying with Shirley is fun.
It's really fun.
Yeah. So one thing that I really enjoyed using it for was asking for recommendations. Alex and I both enjoy coffee. There's plenty of content about that in the videos. But
sure is.
Yeah, we kind of asked like a fairly nuanced question, sort of like, what would sort of like third wave coffee lover like, want to visit in Louisville, Kentucky. And Shirley had a few recommendations. We consulted them, and we possibly would have picked a different one using our own skill set. But the argument winner was, well, Shirley said we should go to Quill's Coffee, so we did.
Excellent, excellent choice. Very happy with it. You can imagine being like an airline pilot also, and just being like, man, I'm getting diverted. And like, what can I even do here? Or I had to go do on standby and go into some random place. Like, where am I going to have dinner even?
Yeah, we did very similar things with lodging. We discovered that Home 2 Suites works for us outside of Lafayette. We didn't know if there even was a Home 2 Suites in Lafayette. We asked Shirley that question, and Shirley was like, yeah, there's two different like Home 2 Suites. So
really
Shirley was helpful, and getting back like answers like that and going to test them out for ourselves. Really fun.
And that's a good example of the hybrid kind of like doing deep, like medium or deep research while also connecting that to a system that responds immediately. And so Shirley basically like, oh, this is ready, gets the data, transmits it to the pilot. Pilot smiles and has a good time.
Yeah.
I mean, for me, I just kind of love the personality of Shirley.
Yeah.
So basically just being able to clown around, which is cool. I mean, Shirley can be professional as well. And we got to figure out, like, not everybody's like us.
Yeah.
But I think Shirley's able to fit a lot of different personality types, which is cool.
I agree. In some cases, the creativity was just kind of astounding, actually. I mentioned at one point that as a kid in Memphis, I used to ride the Zip and Pippin at Libertyland. It was Elvis's favorite coaster, apparently. But Memphis sadly lost the Zip and Pippin about 20 years ago. And we were like, oh, it fell into the hands of some private collector. Shirley was like, no, it didn't. It's at a theme park that's 40 miles from Oshkosh. So when you go to EAA AirVenture next year, you should take a little side detour and go ride the Zip and Pippin again.
Pretty cool throwback from the logbook functionality that we had that included that we went to Oshkosh. So honestly sick.
Yeah, and like a real practical thing that like I most likely will do.
We will do that. Most
yeah,
likely. Just sick. So you're just hanging out in a cockpit most of the time. You're just sitting in cruise doing nothing.
Yeah, it's really good for keeping you alert, focused, and just generally having a good time in the plane.
Yeah. And so despite the fact that it does take a couple seconds to respond to the current models, the current latency, all this other stuff, honestly, in cruise, it's awesome. Yeah.
Yep. Off the back of that, I mean, my next item was that flying with Shirley was useful. We just gave a lot of examples of Shirley being useful, but there's one that I thought was really, really neat, which is that a problem we were mentioning earlier is that there were times when so much stuff would be coming over the radio. The radio had this audio muting feature that would actually prevent us from hearing Shirley and instead kind of like, prioritize irrelevant stuff coming over the radio, feeding it to Shirley, and also making it impossible to hear Shirley's responses. It's kind of a pretty problematic issue.
Really problematic.
And so we had Shirley coming into the G1000 through the aux port in the plane, and we actually asked Shirley, "Hey, is there any way to like get rid of this muting behavior?" So Shirley was like, "Oh, sure, like hold down MUT for 3 seconds or whatever it
chirped
was."
Twice, and it just totally worked, and it was awesome.
Yeah.
And like, we had this giant manual in the back of the aircraft, but like, it was 3,000 pages long.
Yeah, exactly. You could go look it up, but it's like, we were calling it ducking. Like, we like read we later used an LM to find the source material in the manual, and it's called muting. So, like our search term wouldn't have even been right. Like, what do we do? Look in the index? Like, it would have just been like an intractable problem to do. Like, it would be hard on the ground and basically impossible for most normal people in flight.
Yeah, and we were in turbulence that entire time, right?
Yep.
So it's just like you're having your butt kicked in turbulence. You're not going to be opening up a manual, especially when you're trying to do a pour over.
Right. We kind of got lucky that like that particular moment we even heard Shirley's response, because the radio was ducking out so many of them.
Because you're on the instrument flying, then you're trying to do that. The other really useful thing about Shirley was like the fact that the short-term memory, it's just sort of the equivalent of a human short-term memory, which is maybe 5 chunks. An LLM has as long as the context window.
Right, like what was that frequency? What was that acronym?
I really remember what that one airplane said at the beginning, like in between this, like what was cleared for this other. It was like, I'm sure that would work. Not that we care.
Yeah.
But like really, really interesting and being super valuable. Yeah.
Yeah, like you could easily imagine on the ground being like, like, okay, like who said they were crossing the runway first?
Right. And like for me, it was like, what was that frequency again?
Yeah.
Like pretty commonly, if you get distracted before you enter the information, then it's like too late. And it's like, Shirley, can you set we're still working this aspect out because we want to integrate a little bit better with the aircraft in order to do it. But like, Shirley, can you tell us in 10 minutes, like, once, the expect further clearance time is done? And
that's another great example of useful Shirley features. The reminders and thresholds.
We probably need to turn those into priority wake-ups as opposed to the current ones, which can get stepped on.
True. Yeah. Nonetheless, though, it's really cool. Shirley, let me know when my ground speed crosses 140, and you forget about it completely, and then you get you just crossed 140 knots.
500 feet AGL, give me a reminder, 30 minutes. We got to be careful in terms of like what people are actually depending on in flight for in-flight purposes, and if we had to make that really, really reliable, but really useful.
Yeah,
very useful as a backup.
A similar one is like altitude thresholds. As I understand it, right now we can only do one. Right.
Right.
It would be nice to have a mapping so you could do more than one.
Also useful for training.
Yeah.
But you exceeded your bank in one to the left. You exceeded it to your right. It's basically you still exceeded it. Yeah.
But another one, a really cool learning actually, because this wasn't really something that we'd ever gotten a chance to prove out before, is that our offline mode degradation is actually useful. I mean, some of it, we were, if you'll pardon the metaphor, building the plane as we were flying it. But we identified early on that speech to text is really kind of the most problematic bottleneck for getting results back from Shirley. It requires sending audio to the outside world, which requires sort of fat upload bandwidth. And that's exactly what you don't have when you have a satellite dish that fell off your rear windshield.
It's going through the tail cone of your aircraft, yeah.
But you do have a little bit, and there's really no reason why that audio needs to come out of the plane to be transcribed. And that is something that present day models can do really well. And so we were just going to move to on-device transcription.
Besides the peculiarities that can happen, with some of the words and things like that.
Yeah,
we'll figure that aspect out. I actually think we could figure this out.
Yeah, exactly. It just seems clearly tractable today. We've got some refinement work to do, but it's going to work just fine. And this will really take a lot of the network burden out of Shirley in production, which I think really helps to bring it a lot closer to usability in a kind of general aviation context.
And most likely that'll be the first thing we deliver on iPad. So if you're a pilot and want a way to view your transcriptions while you're flying, let us know. In addition to liking and subscribing to this video, of course, which is incredibly important, but also the default thing that's said by a speech-to-text model, if there's actually no speech and it's just quiet, and hey, give me the transcription, it's like 9 out of 10 times it's going to be like and subscribe, which is awesome. Yeah, anyway.
And yeah, this next point, we might edit this one out for video reasons, but yeah, I think that the Air Tour really helped build our credibility. We flew in with an education partner, and we learned from them that we were their first fly-in visitor ever.
Yep.
And you know, that's one of your cooler firsts, I would say.
Yeah.
We saw a lot of how educators use sims, and just like the ways in which conventional sim solutions are really failing the students who need to learn from them. I think it's really interesting that you know, so much of this like complicated hardware exists that sort of aims to simulate, oh, you can look around in the cockpit, or maybe, you know, you're wearing a VR headset as you're like trying to fly the plane, and then an instruction comes down the pipe like, look out your left window, and like you can't see out the left window, or like, you know, open up the flaps, and like you're wearing a VR headset so you can't find the switch, right? Like in a lot of ways, I think this hardware is just you know, it's kind of cool and sort of like, you know, it's fun in concept, but it's just not really meeting the user where they need it to. So I am very excited for our assistant to kind of, I think, really just transform the flight education experience, and we'll be able to have people produce way better content in way less time, and generate it on the fly to suit their particular curriculum needs, and also just sort of distribute and manage it in a classroom setting in a way that isn't a giant headache. You know, it's like we didn't see a classroom that didn't have "Don't change the plane" written on like the chalkboard, and I think the reason people are doing that isn't because they want to kind of like create mischief. It's just more that, you know, if you like hang out in Sims for a while, you quickly get bored because the content is a little boring. Yeah. And it really doesn't have to be. It's just that, like, you know, everything is there except the good curriculum.
Yep.
And so yeah, that's something that I think we're both really excited to bring.
Yeah. So that automated curriculum is really, really awesome for people. So you get the first draft totally automatically, but then also eventually the student, they could have curriculum made just for them too, which is awesome. Right. So I think you're absolutely spot on that.
You're absolutely right.
You're absolutely correct, Joe. Yet again, you've described it better than most MIT professors.
Yeah, so just kind of to recap some of the takeaways. You know, I don't know we need to go in a ton of detail here. I think a really big one that just, you know, we've got to have the ASR be on point. It needs to be fast, it needs to be reliable, it needs to handle well in situations where the internet is going down but still kind of present, which is honestly the most common situation that people are going to encounter if they're flying with any connectivity at all.
Yep.
So yeah, we need to have really solid options for offline ASR, so it's not going to need to be ground-based, like, you know, it needs to be happening in the plane. Once we've done that critical step, everything else can kind of be lower bandwidth and the system will still be useful.
Yep.
But the speech recognition has got to be high bandwidth.
Yep. And there's a bunch of different ways of generating speech. So you can use native iOS. You can use, you know, a bunch of other models that run quickly now. Fortunately, all these things are now just coming off like the press.
Right.
So I think you're right about that.
An analog that I've seen is people talking about how, like, in a way, it's like we're in the dial-up age of communication with models. You know, a 56K connection is actually pretty good for exchanging text with a super fast oracle that can come back at you with some text. Like, that was never the problem. And, you know, we'll be able to do that step quickly, even with a bad internet connection, even with weak upload.
Blinky lights on the bottom of the airplane.
Yeah, you know, whereas that process of tokenizing audio is like not at all something that would have worked well over 56K.
Right.
So that's kind of, you know, that's
Absolutely.
the like online connectivity world as it is. The airborne connectivity world as it is, and we need to build for it.
Yep. Yeah, that's where the world's going.
Yeah. You know, another point, like, we need tools and well-designed user experience. for noisy cockpits, where there's going to be just like a lot of distractions going on, like telling exactly who the pilot is may be tricky under like common realistic circumstances. And so, we need push to talk to work really nicely. We need priority wake ups, and we need the ability to have Shirley like not be like stepped on by other voices that are actually not as important as Shirley's voice.
Yep.
When you're developing an assistant like this, it's often kind of you're encouraged to think of the AI assistant's responses as being the lowest priority, and like, anything else that comes in, if it's over the radio, if it's somebody else's voice, it should always take priority. We've kind of learned from like experiential use that that's not true. There's often really low bandwidth stuff coming in, and we'd much rather hear Shirley. We need to make the product robust to noisy environments, and just make sure that there's always like a way to kind of squeeze through the signal that matters, so that the system can receive it, process it, and respond.
It's such a different experience to what most AI voice systems are for.
Yeah, completely. It's not. It's already like pretty high signal. Like if you're hearing Shirley, it's unlikely that you're hearing something that like has a high like signal to noise. Did I get that right?
Noise to signal.
Yeah, high signal to noise.
It's supposed to be useful, right?
Yeah. Anyway, the point is, most of the time, if Shirley's talking, it is useful, and you want to hear it. That's something that I think we really validated.
Yeah.
A last point that I think is really worth getting into is just we've had a lot of conversations about like degradation of service, basically, like as opposed to like good internet, everything is going great and super fast, high bandwidth Shirley, to being completely offline. And I think what we've really learned is that, at least in the world we live in now, that's just like not nearly such a common realistic like matters for the product scenario as the more common scenario, which is where your upload kind of sucks, but like you actually can talk to ground a little bit using either a satellite or a cellular radio.
Most of the time, if you're a general aviation pilot, or probably also if you're like hauling around like merchandise as a single pilot in, I don't know, a cargo aircraft, you have like maybe 1 bar of cellular. Other times you can pay $50 a month and have a Starlink.
Yeah.
And like a lot of these guys and gals are starting to have Starlinks in their windows they just bring anyway.
Yeah. If you're a CFI or you're a student, most likely you're going to have some level of connectivity in your plane. And if you don't have it and you want it, you can probably get it.
Right.
So it's really like that aspect is just unlikely to be the biggest problem. What is necessary for sure is, okay, like I've got this weak connection. How can I actually like still have a useful system in spite of that? And I think we got a lot of useful data about how you can build a system that continues to be cool.
So Joe, what are we gonna do in order to start addressing the other issues, which are kind of the main issue, which is like delay and sequencing?
Yeah. So a really big one there, aside from just kind of like offering reassuring noises to sort of like help remind the person interacting with Shirley that Shirley is still there. We've also been talking about these audio to audio models. Like, are we saying the name of the model that we like?
We don't have to, but there's like a bunch of stuff made by NVIDIA recently. I mean, there's also
that's probably enough clues to go figure it out if you're interested, but
just recent stuff.
If you kind of are like asking a question, getting back a long response from a model like that, and you interrupt it harshly and unexpectedly mid-sentence and keep talking for a while, it will kind of hold just the way that a human does when a human gets interrupted. And when you stop, it'll kind of like pick back up its context and resume speaking. And like we're talking like milliseconds here. It's like the times for these transitions.
Really excellent.
So it's going to need high bandwidth or running in the plane. Those are basically like the scenarios I think that we can cover well.
Right. And we're like considering some other options that allow us to hybridize multiple models together in order to get the benefits of some, the others. But we've got at least some path to be able to solve the sequencing thing where, you step on Shirley, but also the response time question as well. So we're excited to get into that and be able to talk about that more and demo it once we've got it. But Cool. Is there anything else we should be talking about today, or overall?
I think this is a good place to wrap. But I think I don't know. Like, what's an appropriate adjective for this trip? I would say it's a barnstorming success.
Yeah, I mean, what an air tour! Really, really fun. I think we found that we enjoy using this. We think it's good.
Yeah,
and it's going to get better.
We want to see other people using it. We want to get the data and understand how it's failing for other people and make it better.
Yeah, get the information. We're figuring out ways to, respectfully ask for people to, contribute when they're actually talking about their in-flight stuff. Contribute that in order to make flight safer, in part by helping build Shirley as a co-pilot for pilots. So, really exciting stuff. And thanks for watching. Like and subscribe. And we'll sim you later.
Yeah, click that notification bell. And don't call me Shirley.
Yeah, don't train your ASR system on this. Otherwise, it's going to say, like and subscribe.
And don't call me Charlie.
That's right. All right. Thanks, man.